Howdy, I'm Michael, and I want to thank you for tuning in today. I'm an IT professional in the Houston area, and today we will be covering the Adafruit Feather TFT ESP32-S3 board. This small board has a lot of potential, and I want to walk through the default application that's on this device. First, we get to the Adafruit webpage for our board off of the Adafruit website. Now we scroll down to the Learn section and select the primary guide. I already have that open. Here you see on the left menu with all the different options that you can do for this board that they've added. And the example that we're going to choose is the factory reset option. On the factory reset, we have where we can download the files that allow us to push the default firmware up. And then right below that green button is a source code for reference. And that is going to take us to the GitHub that shows us the default program on the board. Now that we see this code, we can learn about what the board is doing by default. First, we have all the includes for the libraries that can be called in the application. The platform uses an Arduino standard, so that is in there. The LC709203F.H is the file or the library for the charging system. NeoPixels for the LEDs, and the testbed library set of functions to pull data from the board, but also has a few functions for the LEDs. The BME208 is a temperature and humidity sensor that is not included with the board, but you can add it. The ST7789 library is for the TFT display, and finally we have a font that we're going to use on the display. Continuing down, we create an instance of the BME208 or 280 from the library, and it just creates the object. So if our board doesn't have that, it's okay, because the next line creates a Boolean variable called BME found and sets it to false that we can use later in the program. Next, a testbed instance, TB, is created that allows us to call some of those LED functions, some other board things. After that, we create an object for the LiPo charging library that will pull the battery charging state. And then the next two lines are just for the TFT. First creates the display object from the ST7789 library, and then supplies the internal variables that are set for the pins that we need to supply to the function. Those pins are internally set with libraries from Platform.io that will present the pins for most everything on the board. You'll see this in the NeoPixel as well. And then the last in this preload section, we create a canvas for the TFT display. From here, we're in one of the two main sections in the Arduino program. This setup section will only run once at startup, and then the next section, loop, runs over and over forever. Here in setup, serial and display or delay are pretty basic. One opens a serial port and the other just delays the program for 100 milliseconds. Now we hit some of the meat. We have to turn on the display, and it's on the I2C bus, so we set the I2C to output, and then we turn that on with the digital write. Now we do the same thing with the NeoPixel. Notice we're using the preset variables for both the pins for the I2C and the NeoPixel. Now we start with the testbed functions. We'll tell the library the pin and how many LEDs, and then we call the begin that sets up the connection to the LED, set the LEDs to white. Note that this code is unique for this testbed library. Next, we init the display with the resolution of the onboard TFT, change it to a landscape, and then set the font and the text color. Now, we do a test on the LiPo battery library that runs its setup and begins a function. If it fails, sends a plug-in battery to the serial output. Next, we assume the LiPo battery is found and then written as serials with the pack size of 500 milliamp hours. Next, it checks for the BME 280 with the testbed library, and then serial outputs some status based on what it finds. And that ends the setup. Now we create a variable j and we set it to 0. We'll need that later for the LED. In the loop section, we run an I2C scan. There can be more than one I2C port available, so it checks and then displays the code to be able to show it. Next, on a loop that runs every time j is evenly divisible by 5, we basically lay out the screen. We have fills for the background, set cursor to start text, print statements, and the changing of text colors. Then we draw the screen with what we just placed on it with a draw RGB bitmap, and we make sure the backlight is on. And that does the display. We're now out of that J loop, and we call a wheel function that increments J once by each time with a plus plus. This will change the color of the LED on a value from 1 to 255. That wheel will then turn and send data to the red, blue, and green values on the data line to the pixel. And that's the default program. We can see plenty of things that we'd like to use, like the TFT display code that we're going to use in upcoming videos. Also, the preset variables for the pins will come in useful as well. Next, we'll show a simple way of controlling that onboard NeoPixel without having to load a library full of functions that we won't need, which will help with the size of our compiled code, but it's just good programming practice to avoid any unnecessary fluff, which that could be accomplished with our own library, which we may show for both our LED and TFT. We'll just see how that does. Thanks for tuning in, and I'll see you next time.